You know, there's a piece of JavaScript that pretty much every developer on the planet uses every single day, but almost no one can actually explain how it works. So today, let's pull back the curtain and uncover the secret of how JavaScript's simplest values get their incredible powers. I mean, look at this. You've written this a million times, right? You make a simple string, and then you call a method on it, like uppercase. It just works. You don't even think twice about it, because why would you? It feels totally normal. But if you really stop and think about it for a second, how is this even possible? Because when you look at the fundamental rules of JavaScript, this code, well, it shouldn't work at all. It's a real paradox. So to get to the bottom of this, we have to talk about the two basic kinds of data in JavaScript, primitives and objects. And trust me, they play by completely different rule books. It all boils down to this. Primitives are just simple single values. Think of them as incredibly fast, super lightweight. Objects, on the other hand, are the heavy lifters. They're more complex because they're basically containers that can hold a bunch of different values and even functions, which of course we call methods. And just so we're all on the same page, here they are, the 7 official primitive types. And you'll see our hello string from that first example is right there at the top. It is a primitive. It is not an object. So that question is still hanging in the air. How can a simple, lightweight value have a fancy method like uppercase? Well, the answer is a really elegant trick that JavaScript performs behind the scenes. It's called the object wrapper solution. An object wrapper is pretty much exactly what it sounds like. The moment you try to do something object-like to a primitive, like calling a method, JavaScript instantly creates a special temporary object that wraps around your primitive value. This temporary object has all the useful methods you need, and then once the job is done, poof, it just vanishes. So when your code runs str.uppercase, 3 things happen in the blink of an eye. First, JavaScript creates a temporary string object that's holding your value, hello. Second, the uppercase method gets to run on that object. And third, as soon as it has the result, that temporary object is destroyed, leaving your original simple string totally untouched. And this right here is the absolute genius of the solution. We get the best of both worlds. Our primitives get access to all these powerful methods, but they stay fundamentally simple, lightweight, and fast. And you better believe that JavaScript engines are highly optimized to make this whole process incredibly efficient. Okay, so this is all pretty cool, but like any good magic trick, there are some important rules and a couple of exceptions, and you really need to know these to avoid some super tricky bugs. Okay, first rule is simple. The big exceptions here are null and undefined. You can think of them as the most primitive of the primitives. They don't have any object wrappers to call on, which is exactly why you get that famous error if you ever try to access a property on them. Now let me show you a classic pitfall. So while JavaScript creates these temporary wrappers for us automatically, it also lets us create them ourselves using constructors like newNumber. This is almost always a bad idea. Just look at this code. We're creating a number object for 0, and then we're checking it in an if statement. So what do you think? What happens here? We're checking the number 0, which we all know is a falsy value, right? So does the code inside that if block actually run? You bet it does. The code runs, and you're probably sitting there thinking, wait, what? How in the world is 0 truthy? The whole secret is revealed when you use the type of operator. A primitive 0, its type is number, but newNumber of 0 creates a variable whose type is object. And in JavaScript, the rule is dead simple. All objects are truthy, every single one, even an object that just happens to be holding the number 0. So here's the big takeaway, the thing you really need to remember. Just let JavaScript handle the temporary wrappers on its own. For your own sanity and to avoid these kinds of confusing bugs, just stay away from manually creating objects with new string, new number, or new boolean. Alright, to really hammer this concept home, let's look at one final piece of evidence. This is the thing that proves, beyond a shadow of a doubt, that primitives are not objects, no matter how much wrapper magic is going on. Okay, last challenge for you. We have our primitive string hello. Then we try to add a brand new property to it, called test, and set its value to 5. And then, on the very next line, we try to read that property back. What is the alert going to show? The answer is undefined. It's like the property we just set vanished into thin air. And here's why that happens. When that line stirred.test equals 5 runs, JavaScript creates a temporary wrapper object, it adds the test property to that object, and then that object is immediately destroyed. It's gone. So in the next line, alert stir.test runs, JavaScript just creates a brand new, completely clean wrapper object that has no idea that the test property ever existed. And this is the ultimate proof. This behavior shows crystal clear that primitives are not objects. They're immutable. They cannot store any additional data. That whole wrapper mechanism is only there to give us temporary access to methods. It doesn't change the fundamental nature of the primitive at all. And there you have it. That's the elegant, invisible trick that gives primitives all their power without weighing them down. We've just uncovered one of JavaScript's deepest secrets, and it kind of makes you wonder, right? What other magic is still hiding in there, just waiting to be explained?